Alright, welcome to Unit 4. Today we will just be learning about simple manipulator design. We're not going to go over like the whole thing, but we're just going to go over the basics so when the season starts you guys know what to do. Start off by just showing you what I did for this year's shooter, what me and my team did. I'll show you. This was our first drawing here. Now we just started on a whiteboard. We started generating ideas. We were looking online, looking at videos, looking at anything that could inspire us because we were shooting fuel this year, about 6-inch diameter yellow foam balls. And our team decided in our design and strategy meeting that we were going to be using a multi-shooter. So right here, just very like bland, basic like sketches of what we want. A couple goals here, like building the initial prototype, what we're testing for. Like I see we're testing for compression, the angle of the shooter, and rollers versus wheels. Here's just a simple like side plate example. And up here is part of a design that we went with, which shows a rotating hood. So really the whiteboard is just to show your team what you want to do, and this can be done in a notebook with paper as well. Really anything where you just do simple sketches, draw out what you want to make, what you're thinking of. That way your team can better understand and visualize what you're trying to explain to them, and then they can make better judgment on whether or not they think it's a good idea and also add their inputs. Like say somebody wanted to change something on here, all they have to do is just erase it and then add whatever they want to add on here, and then everybody else can see what they're thinking of. Really just this is where everything starts here in the design, and then once you settle on a design, you can CAD up a prototype. If that works, then you can start on the final design. And I'm just going to kind of show you guys what that would look like. So if you want to load up Onshape, go to Create. Just make whatever document we want. I'm just going to name it CAD Unit 4. Put it in my folder here. Then click Create. You'll set this up like I normally do with a parts folder. Throw my Parts Studio in there, and I'm going to name this Shooter Side Plate because that will be the main part of my mechanism. And I'm just going to start with a simple sketch. Now this, what I'm going to show you guys, is a little more of an advanced like CADing feature, which isn't required to make a mechanism, but it makes it a lot easier to make a mechanism. So I'm going to start by just putting a center circle with a construction line up here at this center dot here. Make sure it's coincident with it. And I'm going to make this 4 inches. Now what this center dot or the center construction circle kind of is representing right now is on the shooter it uses 4-inch diameter wheels, little rubber wheels. And the way I found this out is during our prototyping, I was testing rollers and I was testing wheels, like which color, which thickness of rubber, which one we thought worked best, and we settled on these 4-inch orange wheels with rubber on them. So that's where I'm getting this number from. You guys in your own prototype testing would decide what would be best for your manipulator. But in this case, we're going with the 4-inch diameter wheels. There's going to be a wide multi-shooter, and this will just represent the wheels that are kicking the ball out and just the main driving force. Now, also what we have off that, if you go up here to center point arc and go off the middle here, I'm just going to go straight down and make sure that vertical mate is applied. You can kind of see it in the bottom right, and the screen kind of goes yellow, kind of when I go around here and it tries to snap in place. I'm going to go like that. I'm going to go, let's just say up to here. Now I'm going to dimension the bottom of this circle to here. I'm going to make the distance between that, let's go 5.4 inches. Now how I got this number is ball diameter 5.91 inches. In our testing we found 1/2 inch of compression is kind of the sweet spot that we want. Also going to make this a construction line. And now this is kind of the curve that our thing will follow. I'm not going to define this yet because I don't know what angle we want it at. I want to go up here, and in our design we found that we would want another roller up here just to put spin on the ball, but these wheels won't be quite as big, so we are just going to dimension them out to 2 inches and make these construction as well. The reason all of these are going to be construction is because this isn't going to be the actual side plate itself. I'm just giving myself a sketch that I can use to figure out like how to build the side plate, because then I have points that I can base it off of. So now this is tangent to this and it has to stay with it. I'm also going to make it, let's see here. I'm going to set it 1 inch away. That way it always stays next to it towards the top. No matter where I drag this, it'll always stay with it. It can't really move anywhere else. All right. Now another thing that I'm going to do, I want to know the launch angle that I'm going to do it at. So I'm going to create construction lines here. I'm going to create one just kind of going out tangent to this. I'm going to create another one going perpendicular to that one, and then another one perpendicular to that one, as well as making sure that these two are parallel and making everything a construction line. Let me just find this error real quick. A good way to find errors, if everything's going red here, all the red stuff is stuff that's not liking each other, and the gray stuff is fine, so I'm just going to delete the parallel and see if that fixes anything. It's fixed here. Let me make sure it still kind of does what I want. Yes, it does. I'm going to make this tangent to this circle, and then I'm going to go back and make these constructions again as well, because I accidentally deleted that. Alright, now we kind of have, you can see, as we move this, as we move the position of this, it changes our launch angle here. So what we can do to dimension that out is go to the dimension tool and dimension this just from anything flat, kind of like this. So you can see what our angle would be. 180 would be kind of like our 90, and actually I think I can make this a little bit better. Make sure you're not doing the center of this circle and instead doing the line here. And still kind of the same, but see, 90-degree angle is going to give us that kind of straightforward. 180 will kind of give us that straight up. So we want the sweet spot right in the middle of 90 and 180. And obviously I know that, but just to show you guys a cool thing in here that you can do, if there's complex math that you want to do, but you don't want to go into a calculator, figure it out, and then paste it back in, you can do math within the dimension. So obviously it's in the middle of 180 and 90. I know half of 90 is 45, so 180 minus 45, and it will just do that for me. 135 degrees here, and there's that. Another cool thing you can do here is if you click the plus and click Create Variable Studio, this is another advanced kind of part here, but if you click Name and make it Shooter Angle, there can't be any spaces, so I'll do underscore. I'm going to make it a angle, and I'm going to make it 135 for right now. And for the description, sets the angle of the shooter. And now when I go into here, I can just make this, instead of this math problem, I can make it shooter angle. And once this gets really messy and I open it and there's a bunch of things everywhere, instead of having to go through that, find out where it is, or even having to find the part studio, I can just go to the variable studio, change this, say I want to change it to 100 degrees. Now I go back in here, it automatically updates to 100 degrees as you can see, but I do still want it at 135 because that will give us the maximum range. So that's one cool thing that you can do. I'm just going to set these equal to each other just to make it look nice. And this is kind of a start of what you can do. If you want, you can also add like the bottom of the robot on here if you want to dimension off that. But what this allows me to do is everything's a construction line. Now I can start my actual side plate sketch by clicking here. And now, instead of like dimensioning out as I go, I can see, okay, I'm going to need a bearing here. That way I can support the flywheel there, and I'm going to need one up here for these 2-inch wheels as well, because I will be needing an axle through there. Right here, dimension that out to 1.13. Now I have these 2 points, and instead of trying to figure out how to dimension those like in a different way, this sketch just makes it really nice and easy. And it also gives me a thing, okay, now I can kind of start making the plate outline that I want. I would just make like a rectangle kind of like this, And then I would also be able to take points here and make them coincident with this curve. That way, no matter where they go, they always follow the curve, and these would be good if I was like mounting a plate to this or something that the ball follows, or just helping to mount Lexan. I can also offset it from that. This angle allows me to see, okay, hey, I can't put anything in the path of this angle because that is where the ball is going to go. So this helps me figure out where I want my motor, because say without this, I place my motor here, right? I'm thinking, okay, everything's going good. And if I don't catch it in the CAD, which is really likely if I don't have this angle in here, then the motor's going to get hit by a ball and it's not going to work. So with this, I can see, okay, it needs to be, the closest it can be is right here because it's really close to the wheels and it's really close to where the ball is coming out. Give myself a little bit of breathing room. I'm going to put it over out here somewhere. And then this is where we'd use those timing belts that we learned in the last unit. And we would dimension that from here to here. And we would make this whatever length our timing belt says. I'm just going to say it said 3.25. I don't really have one, but that's what I'm going to say. And I'll dimension it up from here because this point will always stay fixed. 10 inches up from the bottom of our shooter. Now we kind of have a central base plate that we can start with. If we can extrude it here, you can kind of see it looks very blocky right now, but this is how I started the shooter this year. This is what that sketch looked like. It's a little more complex, and that turned into this prototype plate, and everything on here is based off this back sketch here. This one's a little messy because it was just like the prototype one, but it's really helpful, and it makes sure that everything's accurate and everything's working good. That'll be it for this unit. Please continue to work on those practice problems. That's the best way to learn, and I'll see you in the next one.